We are now moving into section 6.2. We're still working with decimals, but now we are going to be focusing on operations with decimals. As you can see here in our overview for this section, we are adding, subtracting, multiplying, dividing. We are, of course, modeling those using our decimal squares. We are also going to be learning the paper and pencil algorithms and see how those two things are associated with each other. We'll talk about powers of 10 and how we multiply and divide with those and why. We'll revisit the order of operations and then do a quick revisiting of some of our properties, which we learned before. I won't spend too much time on those since we've covered those a lot in this course already. We'll just note that they work for decimals as well. And then, of course, we'll talk about some mental computations and, of course, some approximations. So we're going to start here with addition. And as we saw with whole numbers, addition of decimals is really the same, right? It's putting together. It's a combining of things. And if we are going to add two decimal numbers, such as 0.47 and 0.36, we can model this with our decimal squares using the ones that are broken into hundredths. Here's what that could look like once you are done with that process. On the left, you see 47 hundredths, which is, of course, this number. And we are adding that to 36 hundredths, which is represented here. So it's really the combining of these two area models to get this entire shaded area here, which is 83 hundredths. Of course, we want to link that to the concept as well. And so we can represent this with fractions if we think about our decimals based on their place values. So 47 hundredths is equivalent to 47 hundredths as a fraction. And 36 hundredths looks like this. And you know that when we add fractions, we add the numerators together, 47 plus 36, and we keep that common denominator. 47 plus 36 is 83 hundredths, which is, of course, equal to 0.83, right? Which is what we showed here. So this is showing that connection piece between fractions and decimals. You need to make sure that you are able to do that as well. Now, when we use our traditional paper and pencil algorithm, which on the competency test, you will probably use that approach, you have to do some aligning of your decimals properly. We'll talk about how we do that. And so if we're going to do this same problem, 0.47 plus 0.36, we would traditionally write those like this and like that. We would align them in this way. Why do we do that? Because it's all about making sure that we are aligning same place values. Hundredths place has to align with hundredths place. Tenths place has to align with tenths place. Just as if these were whole numbers, 47 plus 36, we would line up the ones place, line up the tens place. And it, again, has to do with the visual that goes along with this, right? So we add two hundredths together, the 7 and the 6. Add those numbers that are in that hundredth column, and we get 13. 7 plus 6 is 13. And so we have 3 here, and we carry that 1. I'm going to revisit something we saw in the previous video. This idea of regrouping with the tenths and the hundredths. We saw this online GeoGebra tool. And what we looked at was what happened when we increased our hundredths column all the way to 10, right? We counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it transferred over to the tenths column. And we do it again. We get up to 9, and as soon as we get up to 10, it transfers over, right? There's that idea of regrouping. That's what we do when we are carrying the 1. we had 13 hundredths. 10 of them get transferred over to the tenths column because 10 hundredths is equal to 1/10. That's what we are using right there. I spent a lot of time talking about this because this is essential to your understanding and your future students' understanding of why we do these algorithms the way that we do. Then we have 1/10 plus 4/10 plus 3/10, which is 8/10. And because we were adding hundredths together, we have that decimal point right down there, and we end up with 83 hundredths. Again, this is modeled also in this visual that we showed right there as well. Let's practice a couple of these. You'll probably be doing these with your paper and pencil algorithm, but take a moment to just practice adding these two decimal numbers together. 62 and 47 hundredths plus 114 and 86 hundredths. That's the first one. And the second one is 4 and 39 thousandths plus 17 and 18 hundredths. Pause, take a moment, add those, do a check for yourself. And when we do this first one, when you're adding, it does not matter which number is on top and which is on bottom. Some people always like to have the longer number on top. Doesn't really matter. Some people always just like to put the first number on top. When you're adding, it does not matter. But the key is we have to make sure our place values are aligned. And we can do that by focusing on that decimal point. Then we start and we work from right to left. 7 plus 6 is 13. Regroup, carry that 1. 1 plus 4 plus 8 is 13. Regroup, carry that 1. Again, what happened right there? We had 13 tenths, which was the same as 10 tenths plus 3 tenths. 3 tenths ended up right here. 10 tenths is equivalent to 1, and that ended up right here. That's what's happening behind the scenes. Our decimal point doesn't move. 1 plus 2 plus 4 is 7. 6 plus 1 is 7. And 1 plus nothing is 1. So we have 177 and 33 hundredths. Over here, same thing, 4.039 plus 17, there's my decimal point, 1/8. Many people also like to take this 1/8 and change it to 180, 180 thousandths. Sometimes it's helpful to have the numbers align all the way on the right. It is fair game to add that 0 there because 18 hundredths and 180 thousandths are the same number. Then we add again. 9 plus 0 is 9. 3 plus 8 is 11. Regroup, carry that 1. 1 plus 1 is 2. Our decimal does not move. 4 plus 7 is 11. Carry that 1. 1 plus 1 is 2. 21 and 219 thousandths. Okay, so there we go. Double check on your own addition with decimal skills. So now let's move into subtraction. Subtraction. Okay, so as we talked about back in the whole number section, subtraction can be modeled a few different ways. It can be thought of with the takeaway concept, where you're just removing a value. It can be thought of as the comparison concept, where you're comparing one value to another value and looking at the difference between them. And it can be also thought of using the missing addend concept, where you start with the smaller number and you say, how much do I need to add to get to the bigger number? And so we're going to model all three of those just to revisit them. We might not have seen them for a while. So the first one we'll do is model this subtraction problem, 0.625 minus 0.238. 625 thousandths minus 238 thousandths. And I'll show you what this looks like if we use the takeaway concept. It's going to look like this. This is how we're going to envision it mentally. It's good to have mental pictures when we are doing these operations. Again, one concept is the takeaway concept, which is removing this value. You start with this, and then you remove this amount. For many people, that's the only way they view subtraction, but it's just one of the three ways. So we start with 625 thousandths, which is the whole thing, and then we remove this part and we see what's left. And if we counted all those, we would see it's 387 thousandths. So that's that takeaway concept. The other two concepts are similar in a way, and because they have to do with comparison. And so what we will do is look at this subtraction problem, 0.75, 75 hundredths, minus 0.40, or 40 hundredths. And so we can model this using a visual like this, something like this. And if we first think about the comparison approach, which is our second concept, we compare the two numbers. 0.75 is the entire shaded region on top. 0.40 is the entire shaded region on the bottom. And so with the comparison concept, we're saying how much bigger is this one than this one? And so we can line up these dotted lines, and we see that what we're looking for is this amount right here. That's the difference between these two values and these two shaded areas. And so we can see from it, even if we just count these areas, that that would be 35 of these hundredths blocks, 35 hundredths or 35 hundredths. Another way we can use this same model here is what we call the missing addend. This is one of my favorite subtraction tools. I use this all the time when I'm doing mental math. It's starting with the smaller number here. So you're starting with this amount, and you're saying, how much do I have to add to get up to the top amount, the big amount, the amount that you started with? And so I'm imagining how much would I need to fill in here in order to get up to this entire amount. And so I'm looking at, okay, that would take me 35 hundredths or 35 hundredths to fill in to match this one. Again, that's going to take for you some work, right? To maybe approach subtraction with a new perspective. But it is good to know that all of those work, right? We can do it in all of those ways. So let's take a look at the paper and pencil algorithm, the process that we would use for decimals. Again, it's just like how you're going to do it with whole numbers. Let's start with this problem. It was the one we modeled earlier with our first visual. 625 thousandths minus 238 thousandths. When we're subtracting, we want to put the starting number on top and subtract on bottom the second number. And then we're going to work from right to left, just like we would with whole numbers. Now, at times, we will need to regroup. What do we mean by regrouping? It's knowing that 1/10 is the same as 10 hundredths. In a visual model, when I say that, I'm talking about one of these columns. Let me get a different color. If we look at this entire column here, that is 1/10. But if we look at it as the individual squares, there are 10 hundredths. So these are equal to each other. In our subtraction algorithm, the tenths place is here, the hundredths place is here. So if we borrow from the tenths place 1, we would add 10 to the hundredths place. The same thing occurs if we are working in the hundredths place and we need to borrow and move something to the thousandths place. 1/100th is equal to 10 thousandths. And that's actually the first thing that we have to do in this problem here. We have to do a little borrowing. Can't get those to erase. There we go. Maybe not. We won't worry about it. So we have to do 6 minus 8, but we can't. So we borrow. We borrow from this 3. When we write a slash through it, it's going to show that we're going to reduce its value by 1. We now have 1/100th hanging out in limbo, and we're going to add it to the hundredths column in the form of 10 hundredths. There's currently 6 there. When we add 10, we will now have 16. Now you can either put that 1 right next to the 6 like that, or some people like to cross it off and write 16 above. It's okay either way. We can now do 16 minus 8 to get 8. When we go into the hundredths column, we now are unable to do 2 minus 3, so we have to borrow or regroup again. 6, which was in the tenths place, now becomes a 5, and we've borrowed 1/10. We will add it as 10 hundredths to the 2, and 2 becomes 12. 12 minus 3 is 9. 5 minus 2 is 3. Our decimal point comes straight down, and we are done. 398 thousandths. And I just realized that I wrote down that problem wrong for some reason. I wonder why I did that. Maybe you noticed that as I was going through that problem. I wrote 625 here, but for some reason I wrote 636 right there. You were probably waving your arms at the screen. It doesn't matter. Hopefully the process you saw was the same. It didn't change the process. I just wrote the wrong number here. I apologize for that. So let's look at another approach to this particular problem. It is the same thing we did when we were doing the addition problem, just to connect it to the idea of fractions. You've heard me talk about the importance of connections. If we're going to do 0.636 minus 0.238, if we think about that in terms of fractions, it's 636 thousandths minus 238 thousandths. Common denominator. They're both talking about that same final place value. We do subtraction of fractions by subtracting the numerators. And then we do that subtraction to get 398 thousandths, right? So we can see this is equal to that. So again, making that connection to fractions is really critical for both your understanding of decimals and for fractions. So go ahead, and I want you to try a couple of these on your own. The first one we will do is 0.4074 minus 0.356, and the second one is 15.06 minus 2.743. Go ahead and try both of those on your own and then come back. So this first one, 0.4074, is 4,074 10,000ths minus 0.356 or 356 thousandths. Again, just like with addition, sometimes we like to add a 0 here, just so we have the exact same number of place values in both numbers. Then we can do our subtraction. 4 minus 0 is 4. 7 minus 6 is 1. We can't do our subtraction here, but we can do a little borrowing. Now, some people notice right here, if you view this as 40 hundredths and this is 35 hundredths, you might just recognize that 40 minus 35 is 5. And you can do that subtraction right there. If not, that's okay. We can still do our regrouping. We borrow from the 4, make it a 3, and regroup. Instead of 0, we now have 10 hundredths. 10 minus 5 is 5. 3 minus 3 is 0. We need that 0 right there because our place value, or our decimal point, belongs here. We need our 514 to align with that 10,000ths place. So 0.0514. For the second one was 15.06 minus 2.743. Now this one, you absolutely need this 0 here in that thousandths place, because this 3 needs to be subtracted from something. Common mistake I see is people bring the 3 down. Now it's on the bottom. It needs to be subtracted from something, from 0. So our 60 minus 43, we're going to borrow from that 6. It's going to become a 5. Our 0 becomes 10. 10 minus 3 is 7. 5 minus 4 is 1. We're borrowing again here, regrouping. 5 is in the ones place. We're going to make it a 4. We shift our 1 over here in the form of 10 tenths. 10 minus 7 is 3. Our decimal point stays in the same place. 4 minus 2 is 2. And 1 minus nothing is 1. 12.317. 12 and 317 thousandths. So the last thing I want you to do is try to model something that looks like this. Not that. This. Copy. We're going to use our base, or our decimal squares, right? Our base 10 decimal square grid diagrams to illustrate this problem. 0.43, 43 hundredths minus 3 tenths minus 17 hundredths. So see what you can come up with. Sketch yourself a little diagram. It doesn't have to be perfect, but again, the importance is linking it to these visuals. Take a moment to do that. So I did this. I did this in Microsoft Word using a table. And the way that I did this was, the first thing I started with was this. I started with 43 hundredths, and I shaded in those values. And then I needed to add 0.3, but I viewed it as 3 tenths. So I added in 3 full columns of green, right? You can see I wanted to add 3 full columns of green. But then I thought about it in terms of, oh, could I even shift things around? Because I've got this empty space there. So I thought about how I might reallocate some of those green squares, and I shifted it and made it look like that. They still have the value of 3 tenths. They're just not all in straight lines. Then I thought about the 17 hundredths subtraction. I used the takeaway concept. And so I took this existing shaded part and I shaded in 17 of those hundredths in red. And then in my final picture, I imagined just erasing those, deleting those, and removing them and seeing what we had left. And we would have left how many columns? 1, 2, 3, 4, 5. So 5 tenths, and 1, 2, 3, 4, 5, 6 hundredths. So we would write that as 6.56, 56 hundredths. And so hopefully you're able to use those visuals and make some sense linking the pictures, the visuals to those decimal operations.